We can go back and do number 1 together if you want. I do have my answer key for this posted already, and in one of the 3 videos that I'm posting for today, I did go through number 1 all the way through. So you can listen to me go through that one if you want to. This says to simplify. How many fractions do I have? 1 fraction. 2 polynomials, 1 on top, 1 on bottom, but just 1 fraction. So when it says to simplify here, I'm going to reduce this fraction if I can, which means I need to factor my numerator, and I need to factor my denominator. First thing I always check for if I'm going to be factoring. GCF. Does this numerator have a GCF? No. It almost looked like it did. Which piece throws it off? That negative x right there. All right, so area model and an x. We're going to do that numerator. 6x squared goes up here. And negative 12 goes down here. What goes up on the top of the x? Negative 72. A times c. I multiply those together. 6 times negative 12, negative 72. That's pretty big. What do I have down on the bottom? Negative 1. What numbers multiply to negative 72 but add to negative 1? Negative 9 and 8. So negative 9x, positive 8x. I have to be careful when I'm pulling out my greatest common factors here. When I look across the top, I need something that goes into both 6 and negative 9. 3 goes into both of them, so 3x. 6 goes into 6, but 6 doesn't go into 9, so I can't use 6 there. I need something that goes into both pieces. Down across the bottom now, 8x and negative 12. What would go into both 8 and 12? Some people will tell me 2, which is true, but it's not the biggest. I need the biggest thing that goes into both of them, and 4 is the biggest. Positive or negative 4? Positive. So 3x plus 4 is one of the factors of my numerator. To get the other factor of my numerator, we need to do the columns. What goes into 6 and 8? What's the biggest thing that goes into 6 and 8? 2. What else do these 2 boxes have in common? So 2x here. And then negative 9 and negative 12. What will go into both of those? 3. Positive or negative 3? Negative. A way that you can check yourself to make sure that you got the correct factors. This row times this column should give me this right here. 3x times 2x gives me 6x squared. Oh my goodness. This row times the bottom, this column, first column times the bottom row should give me what's right here. 2x times 4 gives me 8x. And then I can do that with this column over here. Negative 3 times 3x gives me negative 9x. And negative 3 times 4 gives me negative 12. So you can always make sure that the row and the column would multiply together to give you what's in that box. All right, denominator time. We need to factor this guy. Does the denominator have a GCF? No. So no GCF there. So an area model and an x for that. 3x squared goes here, negative 20 goes here. What goes up on the top of the x? Negative 60. We multiply a and c together. So 3 times negative 20. I'm going to need two numbers that multiply together to give me negative 60, but add to give me what? Negative 11. What multiplies to negative 60 and adds to negative 11? Negative 15 and positive 4. Negative 15x, positive 4x. Greatest common factors all over again. What's the biggest thing that goes into 3x squared and negative 15x? 3x. What's the biggest thing that goes into 4x and negative 20? 4. Positive or negative? Positive. So 3x plus 4 is a factor down here. Now my columns. What goes into 3x squared and 4x? Just x. Negative 15x and negative 20. 5. Positive or negative? Negative. X minus 5. Again, I can check my rows and columns. 3x times x gives me 3x squared. 4x times x gives me 4x. 3x times negative 5 gives me negative 15x. 4 times negative 5 gives me negative 20. Will this reduce? Yes. What can I cross out, top and bottom? 3x plus 4, top and bottom. So my final fully reduced, fully simplified answer would be 2x minus 3 over x minus 5. What other problems would you guys like to see me work through? Which one? Number 3, absolutely. All right. How many fractions are there in number 3? 2 fractions. What's between the fractions? Division. When we see 2 fractions with division in between, there should be 3 words that pop into your head that tell you what to do first. KCF, keep, change, flip. Keep the first fraction just as it is. We're going to change division to what? Multiplication. And then we will flip this second fraction. All right, so first fraction stays exactly the same. 9x squared yz over 5z to the 4th. Change the division into multiplication and flip our second fraction. So 50x y to the 4th z squared goes up on top. And now 12x to the 4th y squared is on the bottom. What is in between my 2 fractions now? Multiplication. How do we multiply fractions? Straight across. So I'm going to multiply top to top, bottom to bottom. When I multiply things together, does it matter which order I put them in? Like when I type it into the calculator, 3 times 5, 5 times 3? No. So when I write this down, after I multiply these together, the order that I write things down in does not matter. I'm going to write all the numbers first that I'm multiplying. Up on top, I'm multiplying 9 and 50. And then I'm going to write down my variables. And since the order doesn't matter, I'm going to group the variables that are the same together. So I have times x squared times x times y to the 4th times z times z squared. You guys agree that everything that I wrote down in that numerator is in those two original numerators? Different order, but all the pieces are there. Down on the bottom, I'm going to do the exact same thing. I'm going to put the numbers at the front, 5 times 12. And then I'm going to put my variables. Since I went in ABC order on the top, I'm going to do ABC order on the bottom. So x to the 4th times y squared times z to the 4th. So far, so good? All I've done is just written down all the pieces that are being multiplied. I need to see if any pieces can reduce here. Let's look at the variables first. Do I have x's on top and bottom? Then they're going to be able to reduce. So I'm going to look at just these pieces first. I'm going to bring my thoughts up here. What does x squared mean? X times x. I have x squared, so x times another x, right? What about the x in the denominator? That is x to the 4th. What does x to the 4th mean? X times x times x times x. Anything that's exactly the same, top and bottom, can cancel out. Do I have anything that I can cancel? Yes, I can cancel these x's, and these x's because they're identical. Do I have any x's left? 1. Is it on top or on bottom? Bottom. So when I come over here, it's going to go on the bottom. All right, try the same thing with the y's here. I'm going to bring my thoughts up here. I have y times y to the 4th. What does y to the 4th mean? Y times y times y times y. So altogether I have 5 of them up on top because they're being multiplied. Down on the bottom I have y to the power of, what'd you say? Yep, y squared, y to the 2nd, y times y. Is there anything identical top and bottom? Yes, I can cancel out any pieces that are identical. So I can cancel out 2 of those y's. Which means I have what left over? 3. So would that be 3y? Y to the 3rd. Top or bottom? Top. Y to the 3rd. Same thing with my z's now. I have z times z squared, z times z, over z to what power? Z to the 4th, z times z times z times z. Will any of these pieces cancel?
Yes.
Yep. 1, 2, 3, which leaves me with what? 1z on top or bottom? On the bottom. All right, I'm going to bring those numbers over. We haven't touched those at all yet, but I don't want to get too much going on here. So I have 9 times 50 times y to the 3rd. I have 5 times 12 times x times z. I'm going to try to do the exact same thing that I just did with the variables with these numbers. So I'm looking for factors that they have in common that could cancel. Right now, there are no numbers on the top that match numbers on the bottom, right? Could I rewrite anything on the top so that it would cancel with a number on the bottom? Could I rewrite 9 as something times something, or could I rewrite 50 as something times something? I can do 10 times 5 here. What could I do with the 9? I thought I heard somebody say that. That'd be 3 times 3. Does anything cancel? The 5s will cancel. All right. So I have 3 times 3 times 10 times y to the third in the numerator. I have 12 times x times z in the denominator. I can rewrite as what times what? 3 times 4. Does that let me cancel out anything else? The 3. One of the 3's up on top cancels with this 3 here. Before I get too much more going on, I'm going to rewrite what we've got. Which pieces do I still have in my numerator? Which pieces have not canceled? 3, 10, and y to the third have not canceled out. So 3 times 10 times y to the third is still up on top. What pieces do I still have in the denominator? What pieces have not canceled? 4xz. So 4 times x times z. None of the numbers in the top match the numbers on the bottom, but is there any way that I could rewrite anything on the top or the bottom, or both, so that I could cancel something out? The 10, how can I rewrite the 10? 2 times 5. How does that help me? The 4 is 2 times 2. So what's going to happen? One of the 2's is going to cancel. What do I still have left in that numerator then? 3, 5, and y cubed. Is there any way that I could rewrite the 3 or the 5? No. So I'm going to multiply the 3 and the 5 together and get what? 15, and then y cubed. What are the pieces that I still have in the denominator? Two xz. So 2xz. Fully simplified. I do not have any of the same variable on the top and on the bottom anymore. There are no factors of 15 that will cancel with any of the factors of 2. Fully simplified. What else would you guys like to see? We've got about 10 more minutes. Number 6? Sure. What are we supposed to be doing between those two fractions? It says simplify, we're adding them. What do you have to add fractions together? You have to have the same denominator. When I look for things that they already have in common, it has to be factors, things that I would multiply together to get what I see there. Do these denominators have any factors in common? No. If they have no factors in common, that's like if I'm adding 1/8 plus 1/5. Nothing that goes into 8 goes into 5. Nothing that goes into 5 goes into 8. How would I give that a common denominator? What would I do on a problem like this to give it a common denominator? Multiply the first or the second one, top and bottom, by 8. What about the first fraction? Because that would give me 40 on the bottom down here. Multiply it by 5. So I multiplied the first fraction by the second denominator and the second fraction by the first denominator. That's exactly what I do here. I'm going to multiply the first fraction, top and bottom, by x minus 3. And I'm going to multiply the second fraction, top and bottom, by x plus 5. Since I'm multiplying together, I have to distribute this 1 to both pieces. So I'm going to have x minus 3 in the numerator over x minus 3 times x plus 5. Bring down my addition sign, and I have to do the same thing for this fraction. I'm multiplying 2 to this factor, so it has to distribute to both pieces. 2x plus what? 10 over x minus 3, x plus 5. Do these denominators match now? Yes. This denominator matches this one entirely. So unless this reduces at the end, that's going to be the denominator of my final answer. X minus 3, x plus 5. What am I doing between these two fractions? Addition. So x minus 3 plus everything that comes after it. 2x plus 10. If this was subtraction right here, I would have to distribute the subtraction to everything that comes after it. Because it's addition, I'm just going to add the pieces that come after it. Last thing I need to do before I check to see if it simplifies is combine any like terms there are in the numerator. Do we have any like terms? X and 2x. What do I get when I combine x and 2x together? 3x. Any other like terms? Negative 3 and 10. What do I get when I do negative 3 plus 10? Plus 7. All right, before I know whether or not I'm done, I have to check to see if this reduces down, which means I need to see if there's any common factors between the top and the bottom. Just looking at it as is, does it look like there's any common factors? Can I factor this numerator at all? No, why not? What pieces would need to be there if I'm going to factor it? Yep. I would need an x squared. There aren't any x squareds. Or I could look for what? We could look for difference of perfect squares. What do we always look for first when we're factoring? Is there a GCF here? Nope. It's not a difference of perfect squares. We don't have an x squared. There's no GCF. I can't factor that numerator any more than that. So my final answer would be 3x plus 7 over x minus 3 times x plus 5. Yes, sir. You can leave it in its factored form. The denominators, when we're doing addition and subtraction or multiplication and division, I always leave the denominators in their factored form. Because when I get to the end, I have to see if it reduces. And if I've distributed that denominator all out, I'm going to have to undo it to see if they have any common factors. Good question. The numerators, I do have to distribute because I'm going to have to add those together. So I have to do the top, the bottom you don't have to do, and I would recommend against it. I've got about 4 minutes left. Is there anything else that you guys wanted to see very quickly? All of my worked out solutions are available on Canvas. Let me show you where those are.